So do you want to try the share screen?
So,
hello, yeah, can you try your microphone? You're muted. Hello, yeah, and the camera, yeah, good now. You also share the screen now. Professor Rahman, do you want to try the share screen? Can you hear me? Yeah.
Yeah.
Okay. Can you try the microphone? So can you hear me now?
Yeah, I think my microphone is on.
Yeah, that's good. That's good. That's good now.
Okay.
Yeah, that's good now. Oh, can you put a presentation mode?
Should I keep the screen sharing continue or?
Yeah, that's good.
Later?
I want to do a presentation mode.
Okay. Okay.
Yeah, very good. Okay, please end sharing. I will share the screen now. Okay. So it's 9 o'clock in east coast of US and 7 p.m. in Bangladesh. So let's get started. Okay. Good morning, good afternoon, and good evening. Welcome again to this World River and the Delta System Source to Sink webinar series. This is Paul Liu from North Carolina State University. This webinar series is co-sponsored by National Science Foundation, North Carolina State University, Louisiana State University, State Key Lab of Estuary and Coastal Research, East China Normal University in Shanghai, and Utrecht in Netherlands. So today is our great honor to invite Professor Munsur Rahman from Bangladesh, the Institute for Water and Flood Management, Bangladesh University of Engineering and Technology, come here to talk about implications of incoming sediment in managing the Ganges-Brahmaputra Maham system, Bangladesh. So before I introduce Professor Rahman, I want to also mention this webinar series started from August 2020 during the pandemic. So so far we have already hosted 126 talks. All those talks have already been archived on our YouTube channel. As you can see, if you go to the YouTube Source to Sink, and this is the short link, you can access all previous talks. At the same time, we also maintain a Source to Sink channel on Twitter. So you're welcome to follow us, Source to Sink. And next Wednesday, same time, we have Sergio Chorov from Moscow State University. This is not easy. We rescheduled his talk a couple of times, and finally he feels comfortable to give a talk, particularly in some Lena River. So we know very little in the high latitude river. So he will talk about the Lena River Delta. So please mark your calendar next Wednesday. So Professor, as I mentioned, from Bangladesh University of Engineering and Technology. He, you know, as you can see, he got his master and PhD in civil engineering in Kyoto University, Japan. And his research area mainly focused on consequences of climate change, on disaster management, ecosystem service, and climate change adaptations in deltas, with specifically in this Ganges-Brahmaputra area. So, so Professor, now welcome. You can give the floor to you. Please share your screen and put the presentation mode.
Thank you very much for introducing me, and thank you very much for inviting me in this talk, especially having the opportunity to talk about the Ganges-Brahmaputra Mega Delta, where we are living in Bangladesh. So,
and I will also thank you, because so far among the 126 talks, we have maybe 5 or 6 talks talk about Ganges-Brahmaputra, but you are the first one, the colleague from Bangladesh, to talk about the river system. That's a very good start.
Thank you very much. Actually, this is our privilege to share some of the information that we are considering here nationally and locally, in addition to the global perspective. So I'd like to share or briefly reintroduce the rivers and delta systems in the Ganges-Brahmaputra Meghna system, and especially the potential challenges and opportunities in Bangladesh. And next, I will try to discuss about the river management approaches so far we have adopted and practicing in Bangladesh, with some information that I have summarized on sediment load that is coming to this system and its future potential. And then I'll talk about the implications of this sediment load for river and delta management. This is very vital for our system, especially for Bangladesh, where we are located the most downstream part of the delta. And then we'll try to discuss how we can move forward, and then future collaboration, etc. So if you would like to introduce the Ganges-Brahmaputra Meghna system, in the global perspective, we see something like that. The large river system coming from different countries and meeting the sea over Bangladesh. That means the last part of the country of this system is located in Bangladesh. And it has been attracted many people, and that's why many talks, especially on Delta, we listen in this platform. But the issue that I am planning to share with all of you, the local and national perspective, like the challenges and opportunities in the Ganges-Brahmaputra Meghna system from the national and local perspective. And you see the flooding. Flooding is the most known and widely received attention in Bangladesh, as it is the lowest part of the system. So we have definitely the flood water is coming and passing over the country. Even then, the country is experiencing a number of different kind of floods. Like in the Sylhet Basin, we have flash flood. In the river basin, we have river flood. In the coastal area, we have the tidal floods. And the characteristics of each of the floods are different. And the management approaches for these floods are also different in this country. Especially, we are practicing some kind of flood protection since say 1960s, but eventually we shifted to flood management. And flood protection means we have constructed a number of hard structures in terms of the embankments, etc. But parallelly, we are also practicing the flood warning from the national level to community level, and flood preparedness program, etc. And the next issue that is very crucial for Bangladesh, the land loss or river erosion, that has been receiving a big focus in this country, as many people living in a densely populated country, and if land loss or erosion is happening, then we are really in trouble. So this point is very, very focused. In the coastal zone, we have the salinity problems. So to resolve these problems, we have created a number of infrastructure interventions that are again created some differential problems, like differential subsidence in the coastal zone, followed by waterlogging because of the poor drainage systems provided by these infrastructures. So to solve some sort of problem, we are inviting some other problems. So a long-term vision with in a very intelligent way, we need to develop to manage sustainably the system. And in addition, we have the cyclonic event. So it's regular, we have cyclones are coming, and then big damages are happening. So cyclone preparedness program is another focus of this country. However, all these things are mostly relying on the incoming sediment, how much it is coming. And the river flow and sediment flow is being altered at the basin scale, at the same time in the local scale interventions. So how we can handle the system in a sustainable way for longer time scale. So this is a big challenge, and I would like to focus some of the challenges in this talk. So first of all, if we would like to have a look about the land loss that we say the erosion, then we have the major system like the Ganges, the Brahmaputra, and the lower Meghna, and the Meghna, and this is the Padma. So if we see the land loss are indicating by the red color and gain by the green color. And if we look at the systems, the Ganges system is almost the land loss and land gain are in equilibrium. But in the Jamuna, we have only receiving 15% of the land that we are losing. The similar thing is also true for the Padma. So in total, we are losing land from the river system. And in terms of the estuaries and coastal system, we are having more land in terms of the accretion if you compare with the erosion. But the amount of land that we are losing and receiving cannot be balanced really, because the land, the quality, location, etc., the land that you're losing and then receiving cannot be exchangeable. So land loss protection is a very vital issue, and we have been focusing to this point from the very beginning of this country. And to address this issue in a more scientific way, the graduate students and then researchers are together working in this university and elsewhere in this country. And most of the development projects are focusing how to handle the land loss problem in this country. So in terms of the use of the new freshly sedimented land, we have been tempted because the development work need land and try to get land from the acquired land. But often the acquired lands are part of the entire system. So if we do any mistake, then the new challenges are being welcomed. So this is the location where we have the biggest recently constructed bridge, the Podda Bridge. And in terms of the tidal river system, we are always focusing on if some new lands are gaining, then going to construct a kind of infrastructure. So this is the information about the development work along the meandering river system, which are relatively stable. But in terms of the braided river system, for example, in the Brahmaputra-Jamuna system, we have the system changing very quickly, not in a regular fashion. For example, since 1973, in this certain reach, the sandbars and then channels are changing quite quickly. And to accommodate this thing, it's very challenging, and land loss in this country along these rivers are quite big. Even the protective works are becoming endangered because of the drastic or frequent change of these dynamic sandbars in this river, because sandbars are deviating flow, and sometimes if the design is not considering this kind of dynamic behavior of the system, then it is not sustainable. For example, this is one of the examples of this failure. At the same time, we found that this river is very, very rich in ecosystem. So there is a big dilemma actually. If we want to protect the river without thinking this kind of diverse ecosystem, then we may create some irreversible damage. So the balance is very important. And most of the riverbank protection work and also the river management focused projects we have been introducing in Bangladesh are mostly centered to the Brahmaputra-Jamuna system, because it is dynamic and land loss is quite frequent through this river. So in terms of the approaches so far we have in managing the Jamuna-Brahmaputra system, for example, since 1960s to 80s, we adopted a kind of ad hoc based erosion control structure. So if there is a kind, somewhere there is erosion, then the protection works are necessary because the people demand and also the national demands. But since 90s, when we had a big flood, like in 1987 and 88, then long-term planning started. And then in these long-term plannings, we had two different set of focus. Initially, we had the land reclamation focus until 2017. And then since 2019, we focused on to maintain the braided corridor. That is very important for the aquatic life. So if we look at a brief look at these planning documents, the first set of these documents are focusing on the land reclamation, and another focus is the stabilization of the channel with some bend and node focus. Some other countries have some success story on this way. And the second set of information or planning document are focusing on keeping the braided corridor, but stabilizing some sandbars to reclaim land inside the river. And because of the aquatic importance of the aquatic life that we have been advocating for last 1 decade, the braided corridor concept is recently getting more focus. But whatever the planning document we prepared, we never could finish it actually, because these documents are based on some project, and in some project, some test structures have been implemented. And these test structures are sometimes functioning well, sometimes not functioning well. But beyond these projects, any of these planning documents are not continued. So new plannings, new idea are generating and progressing for the future. So this is the overall situation. So if we look at the planning documents so far, in 1991, we had the concept of node and bend control, not management, especially it's a kind of control structure. It was jointly developed by a team of experts from China and Bangladesh. And after the flood in 1987-88, through the flood action plan programs, the relatively similar but more robust options for the control of node and bend introduced. And to implement these, some of the infrastructures constructed along the Jamuna, especially along the right bank, and of which some were successful, some were damaged, etc. But it is the point to mention that we could not continue this even. And then it came to the focus on land reclamation because the economic development, etc., became very important. And many people involved in this kind of work claim that the channel can be made something like a single meandering channel or double channel meandering channel. And a significant amount of land can be reclaimed from the river, and river doesn't need it. And some approaches how to control these kind of structures have been suggested, and more detail have been prescribed, but without applicability of these, that needs further investigation. And next, if we come to the braided corridor concept, like the river will freely fall within the corridor, and ecological, socio-economic, and environmental services can be ensured within the river. And this is the concept that was developed by our group with BWDB in 2019. And same year, the Jamuna River Economic Corridor, having the similar concept like keeping the braided corridor, but more focus on the navigational channel like river economic corridor, and dredging was one of the focus, and the dredge material can be reclaimed, can be used for the reclamation of some of the sandbars for gaining land. And then same year, we had another plan like from the China-Bangladesh study. So planning for flood management in Bangladesh. So these are also almost similar in nature, but more aggressive in terms of the reclamation of the chores or sandbars to make it flood-free, raise the land, etc. So this will be a kind of area where people can have a flood-free zone or something like that. And towards this plan, the recently new planning, comprehensive plan, again initiated through NODI projects jointly implemented by BWDB and JICA. Fortunately, we are in support from the university to this project. so that we can utilize our knowledge and information. And the target of in this plan is to investigate the adaptability of some of the future plants, whether this can be adaptable or not, and then potential river response against flow and sediment changes, both from climate change and anthropogenic interventions. And more interestingly, try to use a nature-based solution in the implementation phases. So towards this, we had some previous work like development of the nature-based solution for the river sediment management that we have been developing for last 20 years. And then it is planned to utilize, and some of the earlier attempts that we did in this river, that the structure were implemented, and then to control the natural river flow and the sediment flow, the sedimentation can be ensured in the backside, and navigation channel can be ensured in the front side, something like using the natural forces of the river. And we have successful, but there are some problems of what kind of materials can be utilized. So all these things can be comprehensively utilized, and then maybe the next planning document will be emerging. So if we look at the quick check of for what the river system wants to be, then we know from the earlier work that the river geometry, the gradient, the velocity, the sediment transports are playing important role. And without considering these parameters, it's very difficult to make a good plan to river management. And if we look at the earlier work, it's quite old, but it's still valid to use, that the sediment transport, the gradient, these are the parameters are governing the plan form of the river and also ensuring the stability of the river plan. So if the sediment transport is changing, the plan forms are changing. The more the bed load, the braided system, the more the suspended load, the meandering the system will be. So within this, I think it's very important to consider these issues in such a mega plan. And in a braided system, even in a braided system, if the sediment load is changing, for example, if the sediment load is decreasing, this is the case in many of these deltas, then the braided system will experience different set of parameters, and then management of the braided river will be different. If the reverse situation happens, then again we have to think. So based on this input condition, the river plan form will experience some natural changes, and it is important to consider the planning document to be harmonized within the natural system. So with that, we need to understand actually how much sediment is coming to the system. There is a big number of research earlier we had, like from the global community and also from the national level, we have some work like to create a kind of sediment budget. How much sediment is coming from the Ganges system and how much sediment is coming from the Brahmaputra Jamuna system, and how much is being intercepted in different floodplain and the interventions, and how much is reaching to the GBM delta. So at some point, we are using 1 billion metric ton from the earlier works, and more recently, the similar scale of sediment with relatively some schematic sketch how these sediments are synced, and then how it is delivering to the system are created, and then which area are over sedimented, which area is under sedimented, etc. Have been conceptualized. And in most of the planning document, we use 1 billion metric ton year of sediment coming to the system. And if we look at the sediment measurement data that we already collected in the by Bangladesh Water Development Board since 1970s. Then we have the Ganges and the Brahmaputra system. These are the range of the data. For the discharge range, we have the sediment range. And then this range of the data are very important and vital to reanalyze and try to understand what are the recent sediment flux. And we did it like initially we tried to make a summary of the inventory that is available, and we received the sediment data in this station for the Ganges. That is quite variable in different records. And similarly, along the Jamuna Brahmaputra at the Hardinge Bridge, we have the similar variability of this record. And then using the data from BWDB, we constructed a kind of trend line for the average sediment in average. Then we found that the sediment load in the Ganges and both in the Brahmaputra Jamuna system are decreasing. And then trend is also very alarming in these records. And in terms of the combined sediment load that we are receiving, then we try to understand how much combined sediment load is reaching to the GBM system. Again, it is decreasing, and we can estimate some reasonable value from this data. And we can also project, if the similar situation is happening, then we can project for the future as well, how much GBM system is receiving recently and also for the future. But overall trend is quite high. But definitely the anthropogenic interventions are already incorporated in this data, but the climate change effect are not, because the uncertainty because of the climate change, the rainfall, etc., the sediment load likely to be increased. So for the future generation of the sediment inflow to the system, the consideration of the climate variability is important. To this extent, we explored the first of this kind, that what will be the end century sediment flux in the Ganges and Brahmaputra system. And we found that from this study that around 37% of the sediment along the Ganges may increase, and up to 60% of the sediment along the Brahmaputra Jamuna can increase. But definitely, these are considering not the interventions, damming effect, diversion, etc., only the climate change effect. So to consider the damming effect and also the climatic effect, the whole scenario are estimating the sediment load by the end century will be reduced significantly. This is quite alarming. And around 5 million metric ton per year will be reduced. So the basin scale understanding on this issue are very important, and regional cooperation and also the neighboring countries discussion, negotiation between the neighboring countries in water sharing are ongoing, but sediment management is not. So this is the new area that the country is trying to focus on, the trans-boundary sediment management issues. So these are the new insights that, and also the achievements that the system is receiving from the neighboring country. And in terms of the dominant parameters so far, we can make a summary like gradient, flow, sediment transports are important, and sediment transport is dynamic, as we know. So if we would like to make a plan, again, I'm showing this diagram that the changing sediment transport, the nature of the sediment transport are the vital. So for good planning and sustainable planning for the future management of this kind of system, incorporating natural-based solution, the sediment load is very important to understand the dynamic behavior of the sediment load. So this is the one issue that I wanted to share during my talk. And then next issue that is, I gauge many of the members will be interested to have the understanding about the delta management in the GBM system, which attracted many people globally. So for the delta management, we discussed about the sediment load, and we have a summary information like for the average flow condition, the current sediment load in the GBM system can be assumed as 400 million metric ton per year. But for the extreme flooding, like in terms of like the flood in 1998, the extreme condition, the return period of 200 years, then the sediment load can be increased up to 1200 million metric ton per year. So the idea is the amount of sediment that we are receiving in the system are ranging in this two value. In between we have different values, but the average value and the extreme value. Now the amount of sediment reaching to the system are very important for the effective delta management. But there are some questions like how much of this incoming sediment is retaining on the delta surface, and whether the sedimentation can counterbalance the relative sea level rise, and can it be enhanced? And next issue that we need to answer, like how this incoming sediment resource can be utilized in an optimum way for the delta building and also supporting the development projects. At the same time, we are having a number of development works in the system. So more than 140 polders, and most of these coastal zone you can see are intervened in terms of the polder embankment to protect the land against flooding and salinity, to create more agricultural product and other livelihoods. And this has created again big challenges. And as these are then, so often these are creating some problem, that failure of these structures, and the water and sediment cannot enter inside right now. So the differential sedimentation is happening outside, and then differential land elevation is generating inside the polders. The land level is low. So any failure of this kind, creating some waterlogging problems, etc. So again, new challenges we invited, and how we can sort out these new challenges. To sort out these things, and to answer the questions that I raised, we developed Bangladesh coastal model since last 1 decade, using the resources from nationally and internationally collaborative research projects, and where many people nationally and globally work together to develop this model. And we have the boundary domain of the coastal model, and we have then polder information here inside this domain. And we created first of this kind, I think, the scenario to have the experiment in the system, the two hydrological scenario, the average flood condition and then extreme flood condition, and two intervention scenario. For example, the natural stage, we remove these polders and then polder embankment. And to do that, we have a large scale simulation considering the bathymetry of the river system, the coast, etc., that we have been generated for last 1 decade. And with this, the result that we have in the intervened state, we found that the flooding and sedimentation for the average flood and the extreme floods are clustered, and then sedimentation is much higher in the extreme flood condition. And in the natural flooding, where we remove the polders, the flooding and sedimentation are relatively uniform. And in this case, again, the sedimentation is much more in the extreme flooding. And we also found that the sedimentation in the natural state can be enhanced a little bit. So these states already changed the flow sediment regime, and that can be restored to some extent through adequate management of the sediment inside the polder. That is, incoming sediment, we can have a better management. And the range of information that we received from these experiments are something like this. For example, the total input we provided, and then the sediment retained in the floodplain in the different intercoast and also in the different region are also varied. That means the sedimentation potential in each of the region are quite different. And if we try to reclaim land anywhere of this coast, it may again create some problem because the sedimentation potential in each of the region varies. And accordingly, we need to make some planning. For example, if we need to reclaim land in this area, we have a very less potential. But if we need to create a kind of port for navigability, etc., then very less potential here. So these kind of things can be assessed by using these models. And then interesting information that we generated, the average sedimentation thickness over the delta surface ranging from 5.5 to 7.5 millimeter per year. This is the first indicative result. And then the change of what the increase of the retained sediment, we can also have increase to some extent. And the polder, the information of the different system like western, central, and estuarine, we can see here. And the current relative sea level rise, if it is say 5 millimeter per year, then we have the potential to offset it. The interesting point is that we have the resource, something like that. And whatever the resource we have, we can make the best utilization. So these are the information. And then the sedimentation enhancement infrastructure practicing in Bangladesh are since 1990s, we have been practicing, say, like cross dam to create more land. And also since 1990, we are practicing TRM to remove the waterlogging from the polder area. And recently, we are practicing, it was being tested in the non-tidal river, but for the tidal river, first of this kind. And one of my graduate student completed his thesis and implemented in the tidal river how to reclaim land in this area and to protect the bank, something like that. And we found that each of these methods can be useful, but need to see the system level responses, like it may have some gain, but may have some consequences or negative issues. So the system level model need to develop. And since 2019, supported by the government of Bangladesh through Bangladesh Water Resources Planning Organization, we initially tried to develop the sediment management manual under their request, but eventually we found that the system level assessment is very important. And during the inter-COVID period, our very big group with some dedicated modeler developed this model, considering, and then it was developed in the Depth 3D platform, and sediment processes and also the sediment management options we tested. And in this system, the model domain is covering the inter-coast and also the inter-Bangladesh. And then we have some sort of simulation, like the water transport and sediment transport. Simultaneously, we can see for the extreme flooding condition. And then we can decide actually how the natural sediment and water are being transported in the system. And if we have a look like the effect of coastal polder on the sediment transport processes, how it has impact, and then we can see the flood water is coming, and in the coastal borders it is changing, and again it is for the extreme flood condition. We try to capture the information, something like that, in different months. So if we again, there is a very big project in Bangladesh in terms of the development of the port near the Paira area, deep sea port, and then the port need to be raised for the navigability. So we can simulate the cyclone and also the sedimentation in the coupled way, and we can see the sediment concentration is changing as the cyclone is reaching near to the system in the cyclone, and then sedimentation will happen here, and then sustainability of this kind of ports will be in danger, something like that. So in terms of the applicability of BDM to estimate the sedimentation potential by using different methods, we found that in general the sedimentation potential we can assess in the entire country, in the intervened or the present day condition, and also if we remove the intervention, then we can have. And then we found that it is very important to, again, the similar kind of conclusion from the Bangladesh Delta model, that the appropriate management is very important inside the corridor. And in WARPO, sediment management protocol, we tried to test actually TRM, the tidal river management, cross dams, and dredging, 3 options that is planned by Bangladesh government in estuarine development projects, and then in different cross dams planned. At the same time, some synthetic dredging options in the Jamuna and the Ganges, and also to remove the waterlogging, some dredging activity in the coastal zone, and also the Paira-Port effect. Then we found that there are a number of positive impacts of the cross dams, like reclaim the land, but and also increase the conveyance. And dredging has also some good points, like increase the depth, reduce the inundation of the dredging influence zone, and then delta building processes can be useful. But there are some negative consequences, like no net gain of land accretion at the delta scale. That is, in one place we can gain land, but other place we can lose land. And then a number of negative impacts of the dredging, like quickly filled, and then inundation in the nearby area. So in terms of the cross dams, we found that the own method are not effective to manage the sediment resource effectively. And dredging can be useful, but intelligent dredging, like the timing and the location of the dredging, is very important to select. So with all these, we have some achievement, and we have something to achieve more. And then, especially, we need to have a good practice of sediment management inside Bangladesh, as the sediment resource is limited, which is coming to the system. And another issue that is very important about the quality of the sediment and the quality of water as well. And these are the information was missing, especially the quality of sediment and the amount of sediment in the policy planning, and also the neighboring countries' negotiation documents, and which are now incorporated. And I think this can be further progressed to the future collaboration. And the material that I covered is contributed by many national, internationally collaborative projects for the last 1 decade, supported by Bangladesh government, DFID, IDRC, JICA, and in the coming days, we look forward to have more collaboration with all of you. Thank you very much.
Hey, Professor Rahman, this is a fantastic talk, particularly from sediment management point of view. This is great. Okay, for the audience, if you have any question, you can go ahead, unmute yourself, and go ahead and directly ask Professor Rahman. Anybody, if you have any question, go ahead to unmute yourself and speak up.
So some of my colleagues who developed Bangladesh Delta model are also, I believe, attending. So any complimentary comments are also welcome.
Yeah. Anybody? Okay, maybe when we prepare the questions, Professor, I have a couple of questions. First of all, what's the rough estimate of the sand mining? How much the sediment removed every year from the delta system?
The estimate of the sand mining is not available in our record, and in most of the sand mining are having not in a legal way.
Yeah.
So unfortunately we don't have, but we can gauge the significant amount of sand is mining from the system for different construction works and other things. Yeah.
This is kind of also a common problem for many South Asia large river delta system, all the way from Mekong, the Irrawaddy, and even the Ganges. The illegal, even the small boat sand dredging or mining is unknown, but if collectively there could be a large number.
Yeah.
And another question is, it is fantastic if we can try to trap more sediment on the delta plan, then we can, build the land and reduce the bank erosion and also mitigate the subsidence. It's great, but at the same time, because the import of the sediment is, not changed or even reduced, So, but if we trap more sediment on the tidal plan, on the delta plan, that means less sediment will reach to the ocean. So what's the impact of that, let's say, shore fees and water, or even the offshore part? I mean, that's the maybe unknown or any study?
Yeah, actually, the exchange between the fluvial and ocean sediment, and also as the system is tidal, so we are receiving significant amount of ocean sediment again returning back to the system. So this part we could not quantify in terms of how much the sediment is becoming being exchanged, etc. And these are the area actually we need to explore in the future, and also because in a very last work during the COVID period that we developed the Bangladesh Delta model, it was the focus of developing the model. Now I think we are in a position to implement the system to explore different issues. Yeah.
Very good. I think a couple in tidal channel observation, even combined with the model simulation, will help us understand the exchange. Yeah. Okay, let's hope the audience can read some questions. Yeah, go ahead if you have any question.
Hello,
Yeah,
hello,
go
sir.
ahead.
Yeah, sir, this is Esha Sheikh from Bangladesh, and thank you very much for your resourceful presentation. Actually, I'm at Warbo, and I talked to Umas in the last recruitment process to you, but I have a little question I want to know from you. From the previous study, we saw that the sediment budget is decreasing in the Bay of Bengal, but in 2015, Darby Itel worked on sediment budget, and they predicted by hydrogen model, and they show that at the end of 21st century, the sediment budget would be increased in the GBM system. Then what would be actually the reason that the sediment budget will be increased at the end of the 21st century?
Yeah, thank you. So the idea is to, during the discussion, I talked about this. This model is considering only the effect of climate change. That means the effect of increase of rainfall intensity, etc. So we have three different scenarios, like the business as usual and drier and then wetter scenario. And as the rainfall is likely to increase because of the climate change, so in the natural condition, the generated sediment by hydrogen will also increase, something like that. And but we mentioned here that cannot be realized in reality because of the effect of the anthropogenic interventions like damming, etc. So it was this is the reason the sediment is likely to increase, but realistically we cannot receive it because of the damming.
Yeah.
Okay.
Okay, thank you, teacher. But yeah, if current situation is sediment is decreasing, budget is decreasing, and in the future we can predict that the sediment budget would be increasing, then what would be the actual implication for Bay of Bengal? Is it for our blazing or something river system that we are expecting in near future?
I don't have very clear idea about it. So as you are in ORPO and we are working with ORPO very closely, so maybe we can have further discussion on it. And then
okay, thank you, sir.
Anybody else?
I have a question. Can I ask?
Go ahead.
Yes. Thank you for your presentation, and it was a really informative, really great presentation. So my question is, in the near future, we are looking at a intervened system and also a system heavily affected by climate change. So if we have to weigh the significance, which one is more significant, climate change or anthropogenic intervention for the rivers of Bangladesh?
Yeah, it's a big question. We, to accommodate both, actually we say the anthropogenic climate change open. So we cannot ignore actually. So the development, the anthropogenic interventions we cannot ignore, but we should be tricky enough, like to have a good trade-off between the development and the natural balance. So that's why we try to highlight some of the ecological resources, the value of the ecological system in this kind of rich, diverse ecosystem, rich environment. So maybe when we started talking about ecosystem, then people did not listen about it. But gradually, like the river corridor system, when 12 years back, when we started talking about the corridor system, most of the people ignored and talked to us that it is not necessary for this country. But we tried to convince, and eventually, if it is, so I think we need to have a good balance.
Okay.
Thank you.
Yeah. Thank you very much.
That's exactly right, Professor. Because this system is so fragile, particularly during the tropical storm coming and the circling, because Bangladesh experienced one of the largest, severest storm surge. And so that's the death toll is very high. And the same thing happened the next to you, their neighbor, about the Irrawaddy River Delta system. And so I think, is a social science, human impact, climate, this both working together, we need to understand both, So any other question? So one more question. How about the saltwater intrusion situation over there?
Sorry, I couldn't follow. Yeah, Paul.
No,
Yeah.
About the saltwater intrusion.
You mean the salinity intrusion or something like
Yeah,
that?
yes.
Yeah.
Rainwater.
Yeah. So the salinity intrusion is a problem in the coastal zone, and if the we have investigated these issues in the system like the GBM, and then if the upstream discharge, sea level rise, etc., are changing, then the impact of the saltwater intrusion will be different. And some of the issues will create some local problem, but some of the issues will create the entire problem. So sea level rise is one of the important dominating factor to increase the overall saline water intrusion in the system. And I think this can also be detailed, analyzed by the Bangladesh Delta model that we are taking in the surface. So the problem is with the data. So we need to have a continuous measurement system, like to support the model. Any change of the system, then the data collection system need to be have a robust way we need to develop. For example, for the sediment data, we have very scanty and limited data, and we don't have quite good faith on the sediment data. Like other data, we have the limitation. So Water Development Board are the mandated institution, and I think we are in touch with them. I think they will enhance this part in this
good. Yeah. We still have a lot of work to do. I mean,
yeah.
So okay, is there any other question, comments for Professor Rahman?
So I think we need to continue the work. The beauty of this piece of these works are that we initiated these activities with some dominant input from the overseas international researchers, but we developed and grown at home. And our team is now very strong, and we developed, and we started developing the Bangladesh coastal model jointly. But when we developed Bangladesh Delta model entirely by the national scientists. Oh. So this is evolving, and any collaboration from other country, like with some precise, say, subsidence measurement, with some precise sea level measurement, etc., we can incorporate in our system model, and that can be useful for solving the problem in the longer time scale. Yeah. So any collaboration are welcome. Definitely to work with us. Yeah, definitely. I think it's very important for more collaborations. And recently, as you know, we studied the Mekong Delta for a decade. And the last couple of years, we studied the Ganges-Brahmaputra. And most recently, we get some fund to try to start a new project on Indus River Delta. So Pakistan definitely is important in the South Asia, particularly for us to get a very good understand of between the climate and human impact on the large river delta systems. And also, as you know, our partner East China Normal, the State K Lab, they initiated the decade for the large delta system. So I think Ganges-Brahmaputra, definitely your delta river system is a big candidate. So the great.
Yes, Paul.
Oh, Xiu Zhen.
Maybe
Okay,
I
you are
can-
here. Okay.
Yes,
You want to say
I can add
something?
something. I'm from the State Key Laboratory of STR and Coastal Research, East China Normal University. Actually, the Ganges-Brahmaputra Delta is one of the key partners of the Mega Delta program. It's also one of the core partners of the, we have a joint laboratory sponsored by the Shanghai municipality. So in this joint laboratory, we have 4 partner deltas beyond the Yangtze. One is Brahmaputra, Ganges, and another is Indus River Delta, and also we have the Nile, and also the another one is called Danube.
Daniel. Okay, great.
So these 4 plus Yangtze, so totally 5 are partners, key partners for this joint laboratory. So currently we are working together with Chittagong University, and at least 2 or 3 of my colleagues are currently in Bangladesh now. Maybe I can contact them and see if they can visit your university during this, because they are currently there now. So maybe I can get you contacted with each other.
Thank you.
And see.
We will be happy to accommodate the visitors from your laboratory. And
Yeah,
you're welcome.
Those people are working on biogeochemistry, but we do have a large group of people working on hydrology and sediment and morphology in our laboratory. So the Chittagong University collaborators are also, most of them are for fishery and biodiversity. So you are not compete with each other, but we are more, we can collaborate without competing with Chittagong people, I think.
That's great. That's great, Xiu Zhen. Thank you very much for the information. I think you can contact Professor Rahman directly if you two can communicate. And
yeah, you can send me his email.
Okay, sure, I will. Okay, great. So now it's already more than an hour, and thank you very much. I think also the interesting discussion, and this is definitely what we need, and we will continue. And again, next Wednesday is we have a colleague from Moscow State University from Russia talk about Lena River Delta. It's not easy, but finally we're able to give a talk, and so I'll meet you next week. Okay, Professor Rahman, thank you so much, and it's a fantastic talk. Again, this talk is also available on our YouTube channel. Okay, I see you. Bye bye.